To understand negative exponents, let's consider the quotient rule. If you have the same base, b to the m over b to the n, the answer is b to the m minus n. You take the exponent in the numerator and subtract the exponent in the denominator, and you just write the base ones. So let's do it for this problem, x squared over x to the fifth. Since the base is the same, x, take and subtract the exponents, and that gives x to the negative 3. So therefore, x squared over x to the fifth equals x to the negative 3. Now, let's do this another way. X squared over x to the fifth also could be thought of as x times x over x times x times x times x times x, which we can cancel out 2 x's in the numerator and denominator, leaving a 1 in the numerator, remember? So this would mean the answer is 1 over x cubed. So doing the problem by writing out the meaning and canceling, we get that x squared over x to the fifth equals 1 over x cubed. And in fact, those mean the same thing. So when you see x to the negative 3, it means 1 over x cubed. So let's see, if you had some base to some negative number, so let's pretend like n is 2, or in this case n was 3, in other words n's a positive number, then b to the negative n means 1 over b to the positive n. And that's the meaning of negative exponents. When you see negative exponents, you could think of it as a fraction. So that's the rule for what a negative exponent means. Now usually in algebra, we write our answers with positive exponents only, and that's why it's important to understand that that's what b to the negative n means. Here are a few problems for you to try. I want you to write down the meaning of each of these, and then I want you to simplify the first 3 since they're numbers. So put it on pause and try that. Okay, so the first one, 4 to the negative 2 means 1 over 4 squared. 4 squared is 4 times 4, so this is 1/16. 5 to the negative 1 means 1 over 5 to the first power, so that's 1 over 5. 2 to the negative 3 is 1 over 2 to the positive 3, so that's 1 over 2 times 2 times 2, or 1/8. And the last one is 1 over x to the fifth. And we can't simplify that because we don't know what x is. Here are a couple more. A lot of people do this first one incorrectly, thinking the 2 also gets put in the denominator, but the exponent of negative 4 is only on the x, so the base is x. So 2, you don't see it written this way, but it's really 2 to the first power. So that 2 will stay in the numerator, and x to the negative 4 is an x to the positive 4 in the denominator. So now you could have thought of this a little bit differently. You could have broken it down as that means 2 times x to the negative 4, which is 2 times 1 over x to the 4th, and then finished by writing that as 2 over x to the 4th. The simpler way to do it is to take anything that has a negative exponent in the numerator and put it in the denominator with a positive exponent, but only the base that has the negative exponent. So let's look at the second one. There's only one thing that has a negative exponent on it, and that's the x. So in this case, the 4 and the y squared are still in the numerator, but the x cubed is in the denominator. Okay, how about you trying this one? See if you could write that without negative exponents. So that's the goal here, to write the answers without negative exponents. Put it on pause and try it. Let's see how you did. The only ones that have negative exponents are these two. So I want to leave the 2y squared in the numerator and the x to the fifth and the z to the first, which means z, then go in the denominator. Okay, what would you do if you had a negative exponent in the denominator? Well, you could go ahead and take the meaning of that and write that as 1 in the numerator that's already there. Then x to the negative 3 means 1 over x cubed. And then that means 1 divided by 1 over x cubed, right? Which means 1 times x cubed over 1, which means the answer is x cubed. Well, that's kind of a long way to get there. Or, more simply, if you have a negative exponent in the denominator, it means you could write it in the numerator with a positive exponent. If there's something left in the denominator, you would write the denominator. So if I had, let's say, 5x to the negative 2 over 3 to the negative 1 y squared. Let's look at this problem. There are two things that have negative exponents. This one and this one. So the 5 stays in the numerator, the y squared stays in the denominator. But we need to move anything that has a negative exponent. So x to the negative 2 is in the numerator, so it goes in the denominator as a x to the positive 2. 3 to the negative 1's in the denominator, it goes up to the numerator as a 3 to the positive 1. So we have 5 times 3, or 15, and in the denominator. I like to write it alphabetically, but you don't have to, so I'm just going to write x squared, y squared for the answer. All right, here are 3 more problems for you to try, so go ahead and put it on pause, try it, and then we'll see how you do. Okay, for the first one, we've got 5 to the negative 2. So we need to move that down to the denominator, but you'll be very careful here. What would be left in the numerator? 1. There's always a 1 left in the numerator or denominator. So when this comes down, it's 5 squared. Now, x cubed, that's already got a positive exponent, so we leave it. So remember, our goal here is to simplify and make sure we write all our answers with positive exponents. So there's that one. So let's do the next one. There's only one that has a negative exponent. The 2 then stays in the numerator, and I've got x squared times x to the 4th. Now, we can simplify the denominator using the rule for the same base. You're going to add exponents, so that's x. And that's the product rule. 2 plus 4 is 6. And this last one, both of these have negative exponents, right? So what I could do is put the m to the negative 5 is the m to the 5th in the numerator, and m to the negative 2 in the numerator is the same as m squared in the denominator. And now I could use my quotient rule by subtracting. 5 minus 2, so I have m cubed. My suggestion is to usually take any negative exponents and rewrite them with positive exponents by moving it from the numerator to the denominator or vice versa. But you could also use the quotient rule at the beginning of the problem. So if we take this problem again, m to the negative 2 over m to the negative 5, you can also use the quotient rule. Since the base is the same, you write the base once, and you take the numerator exponent minus the denominator exponent. That would be negative 2 minus a negative 5, or negative 2 plus 5, which also gives you the answer of m cubed. So as long as you're using one of the correct rules from the laws of exponents, and my suggestion is use one rule at a time and be careful, then there often is more than one way to work these problems. For instance, this is how you could work this problem. See if you could take this problem and try working it a different way by using the quotient rule first. Okay, be careful here. The 2, that's just there as a 2 still. And now if I subtract my exponents, I have negative 4 minus 2 using the quotient rule, which is 2x to the negative 6. And at this point, since I have a negative exponent, I now need to move that down to the denominator as 2 over x to the positive 6. Okay, so that's pretty much the introduction to negative exponents. It can get more complicated, but let's start here.